Part 2, this is for questions 7 to 12. Question 7 is coming from trigonometry. They are saying part A, show that what is on the left side here is equal to what is on the right side there. So I'm going to begin with the left side to prove the right side. You can also start from the right side to prove the left side, okay? But usually the simplest way is to use the left side. The one that looks complicated, you start from there. So this one is going to be to find the common LCM. I'll multiply the denominators, then I multiply this with that, and then this with that. So we shall have sine of theta times 1 plus sine of theta, and then this one multiplies with this. So minus sine of theta, then times 1 minus sine of theta. Then down here, we are having 1 plus, 1 minus sine of theta, then times 1 plus sine of theta. Then from here, what are we going to do next? Open the brackets. So you will have sine of theta plus sine squared theta. And then when we open here, we shall have minus sine of theta, and then a negative times a negative, you get a positive. So we shall have plus sine squared of theta. Then we shall divide by, this is a difference of two squares, okay? So we shall have 1 minus sine squared theta. If you want, you can take your time and you expand that, but this is the difference of two squares. Then from here, this sine here cancels with that, and then we shall have sine squared plus sine squared. That one will give us 2 sine squared theta. And then using the Pythagorean identity in trigonometry, cos squared theta plus sine squared theta is always equal to 1. So 1 minus sine squared theta is cos squared theta. You see that? Now, sine over cosine is a tan. So we shall have our answer out already as 2, then tan squared theta. And that is that. Part B, hence, meaning begin from where you have stopped, or find a way of using what you have gotten in this question here. So hence solve the equation. This one is equal to 8. Already we have seen in part A that this one on the left side is 2 tan squared theta. Then we equate to 8. Divide all through by 2. We shall have here a 4. Then we take the square root on both sides. Then we shall have plus or minus 2. That means I'm going to have tan of theta, which is equal to 2. And then I will also have tan of theta, which is equal to negative 2. Now, I'm going to consider the quadrants where tan is positive and where it is negative. So this one is positive. Now, tan is positive in the first quadrant and third quadrant, okay? In the second quadrant, it is on a sign that is positive. In the fourth quadrant, it is on a cosine that is positive. So moving from here, we begin from 0, then this will be 90 degrees, this will be 180 degrees, this will be 270, and then by the time I come back here, this will be 360. So if I project a theta here, then also this other side, opposite angles are always equal. Then the same thing here, theta, and then also here theta. So to move from here up to here, it will be 180, then minus this theta, not so? So we shall have 180 minus theta. So in other words, moving anti-clockwise is positive. Then when we move clockwise, the angles are negative. Now to move from here up to here, it will be, this is 180, then plus the theta here. So we have 180 plus theta. And then here, you move like this up to here, that will be 360 degrees minus what? Theta. Now, here, tan is positive, right? So our theta then shall be equal to the arctan of 2. And then here, our theta will be equal to the arctan of negative 2. Your calculator must be in degrees because the domain is given in degrees, okay, from 0 to 180. So shift, then turn, and then we put a 2. That will be 63.4. So 63.4 degrees. So that is the first one. Then the next one, where tan is positive, will be 180, then plus this theta you have gotten. But this would be beyond the 180, and yet our domain wants us to end here. So I'll leave that. Then this one here, it's a negative. So when you come to this calculator and then you put a negative here, okay, the calculator will give you negative 63. That means you are now going to move clockwise from the horizontal axis. But now, what you are going to do, you ignore the negative. I always say ignore the negative. When you ignore the negative, automatically you get the acute angle, which is 63.4. Then you go to the quadrants where tan is negative. Tan is negative in the second quadrant and fourth quadrant. That means I would say, to get the angle in the second quadrant, I would say 180 minus the acute angle, which you get after ignoring what? The negative on this, okay? So this one will be 180, then minus that 63.4 degrees. So that means our theta is going to be 63.4 degrees, and then the other one is going to be, so I'll come to this, then I say 180 minus that, and that will be 116.6. 116.6 degrees. This is to one decimal place. We give angles in degrees to one decimal place, and that is that. I'm not going to find the other angle here where tan is negative, because this will be in the third quadrant. It will be way beyond the 300 and what? I mean the 180. So those are our answers. Question 8. A geometric progression has the first term a, the common ratio r, and the sum to infinity s. A second geometric progression has first term a, common ratio capital R, and sum to infinity 2s. Okay, now we know that sum to infinity is given by a out of 1 minus what? R. Okay, now s is equal to, that is the sum to infinity of the first one. It is going to be a out of 1 minus r. Then the next one, the sum to infinity, is given by 2s. So we shall have 2s, which is equal to, its first term is also a, and then the common ratio is capital R. So we shall have 1 minus capital R. Now we are going to solve these two simultaneously. S is equal to this. So I'll just get this and then I substitute it here, right? So this implies that we are going to have 2, then a out of 1 minus r, then is equal to a out of 1 minus r. When you divide all through by r by a, our a is going to disappear, right? Then we shall have 2 out of 1 minus r, which is equal to 1 out of 1 minus capital R. Then we can cross multiply. Then we have 2 minus 2r, which is equal to 1 minus small r. We are supposed to express small r in terms of the capital R. So bring this small r this side. So we shall have r, and then take everything this side, not so. Then r is going to be equal to, there is a 1 here, then subtract a 2 when it crosses. Then when this one crosses, because it is a negative, then it will become a positive. Don't you see that our r is going to be, this is 2r, which is positive, so I write the positive first, and then this is a negative, so it is 2 capital R, then minus 1, and this is exactly what they wanted us to show. It is now given that the third term of the first progression is equal to the second term of the second progression. Okay, now the third term of a GP is given by AR squared. Okay, now they said that the third term of the first progression, that will be AR squared. Remember, the common ratio of this first one here is small r, and then the first term is a. You see that? Then for this one, it is capital R. Then they have said that this one is equal to the second term of the second progression. So the second term is given by A, then capital R. You see that? Of course, A will go because both of them have the same first terms, I think. Yes, because they said the first term here is A, and then the first term here is also A, not so. So that is what we shall have there. Next, now we have R squared is equal to what? To R. But you know that small r here in part A is equal to 2r minus 1. So we square this, then this one is equal to r. We open the brackets here, square this one here, you will have 4r squared, and then 2 times this times that. That one will give us negative 4r. And then you square that negative 1, you get a 1, then it's equal to r. Then you can bring this one this side, you will have 4r squared, then minus 5r, then plus 1, which is equal to 0. This is a quadratic equation which we can solve. Okay, so let's use the calculator and then we see what we get. Mod, then equation is option 5, and then quadratic is 3. The coefficient of r squared is a 4, the coefficient of r is minus 5, and the constant part is 1. Then we shall have a 1 and then a quarter. So capital R is equal to a quarter, and also capital R is equal to 1. So these are roots. You need to give us the fractions from which these roots are coming, because remember, whenever you form a quadratic equation, you must show the attempt, okay, for solving that quadratic equation. So you cross multiply, that one will give us 4r, then bring the 1 here, will be minus 1, okay, then bring this one here, you will have r, then minus 1, like that. Now here you will get all your marks because you have shown the examiner the attempt to solve the quadratic equation using factorization method. Now for sum to infinity, because in the first part we were given sum to infinity, r ranges from 1 to negative 1, so it is within this, okay, or you are going to have sometimes we write it as like this: the modulus of r then is less than 1. You learn modulus functions in A level, that is pure mathematics 3, okay, and that is the first chapter. So that is that. Now that means I will take my r, the one which falls within this range. I cannot take 1 because 1 is not included here, so r is going to be a quarter. Do you see that? But now after finding that a quarter, we have to find the value of small r, not so? So right from here, using this one here, r squared is equal to r. So I will have my r here will be equal to the square root of a quarter, which is going to be what? A half. Or instead of using this one, I can actually use r is equal to 2r here minus 1. So suppose because when you take the square root here, you're going to have plus or minus a half, okay? Now our r here is a quarter, then minus 1. So you'll have this one as a half minus 1, then you get your answer as a negative what? A half. So I'll take this one here. Here you're having two values, you see that? But using this one, I can confirm the value that we are supposed to use. Now, sum to infinity s is equal to a, okay? A, then out of 1 minus r. So this is a, we don't know it, then 1 minus our r is that. So we have a, and then you're going to make this one a positive. So 1 plus a half, that is 3 over 2. That means this one will somersault and then goes there. That means your s is now going to be 2a out of 3, and that is that. And I think they told us to find s in terms of what? A. So that is our answer. Question 9. The diagram shows a circle with center A passing through the point B. A second circle has center B and passes through A. The tangent at B to the circle intersects the second circle at C and D. Then the coordinates of A are these and the coordinates of B are these, but A, find the equation of the tangent CBD. Now, you know that the tangent and the radius are perpendicular, okay? So we shall have to connect the A here to the B. Remember, this one here is a tangent to this circle. Are we there? So using circle theorems, those ones will be perpendicular. Now, our A here is negative 1, 4. So negative 1, 4, that is our A. And then our B is 3, 2. So we need to find M1. Change in Y, so I will have 2 minus 4. Then out of 3 minus 1, not so? Then this one will give me negative 2. Then this one will give me a 4. Then we shall get negative a half. Now, that is the gradient of AB. Now, since this tangent here is perpendicular to the radius here, the line AB, then I'll use the other principle that for two perpendicular lines, then the product of their gradients is always equal to negative 1. So that means M2, or the gradient of tangent CBD, okay? This one will be the M2, so will be equal to negative 1 out of this negative a half. Then you get it as a 2. Now, to find the equation of a straight line, you must get the gradient and at least one point through which a line passes. So using y minus y1, which is equal to m into x minus x1. Now, this line CBD is passing through the point B here, okay? The point B is 3, 2. So that is the one that I'm going to use, okay? So y minus, our y1 is a 2, then our m is a 2, and then x minus, our x1 is a 3. Then y will be equal to, open brackets here, you will have 2x, then minus 6. Then when this one crosses, it becomes a plus. That means the equation of that tangent CBD will be y, which is equal to 2x minus 4. And that is that. Then part B, find the equation of the circle with the center B. So to find the equation of the circle, we need the radius, okay, and then the center. So that equation of the circle with the center B, which one is it? With the center B. This is the one here, okay? This is the circle. So we need to get its radius here, okay? So we need to get the length of the line AB. Then after that, its center is B. You see that? Now, we have our A as, let's go back, negative 1, 4. Negative 1, 4. Negative 1, 4. And then B is 3, 2. Then radius, the length of the line AB is actually the radius, which is going to be equal to the square root of the change in x, that is 3, minus 1, which will be a 4, not so? Then squared, then plus. The change in y will be 2, then minus 4, 2 minus 4 squared. So we shall have this one as the square root of, so this is 4 squared, that is 16, 16 plus, this one is a 4, that will be 20, so root of 20. Then equation of the circle is going to be x minus, remember the center is B. B is the center. So x minus 3, then squared, then plus y minus 2, this one is squared, then this one is equal to the square root of 20, and then we square that. So finally we have x minus 3 squared, then plus y minus 2 squared, and then this one will be equal to 20. This will be the equation of the circle with center B. Then part C, find by calculation the x coordinates of C and D. Now, when you go back to this one here and you look at C and D, okay, there is this CBD is the tangent. This tangent here, okay, is intersecting with this circle whose equation we have gotten at point D and at point C. So that means I'm going to get the equation of this tangent, then I solve it simultaneously with the equation of this circle here. Are we together? Okay, so let's do that and then we get done. Now we have y is equal to 2x minus 4, the equation of the other tangent CBD. And then we also have x minus 3 squared, then plus y minus 2 squared, which is equal to 20. Now substitute this one in here, okay? So where there is y, I'm going to put this 2x minus 4, then there is a minus 2 squared, then this one is equal to 20, then we have x minus 3 squared, and then this one will be 2x minus 6, then what? Squared, which is equal to 20, okay? 20. And then from there, what are we going to have? I can even simplify it. Okay, you can open the brackets, okay, and then you solve that, okay? Or I can even simplify it this way, and I say this is x minus 3 squared. Now a 2 is common here, so I'll say this is a 2, then x minus 3, then this whole thing is squared, which is equal to what? 20. And then what else do we have? X minus 3 here, then plus square the 2, that would be a 4, then x minus 3 squared, which is equal to 20. Now when I factorize this one out, I'll have a 1 here plus the 4, so we shall have 5 of x minus 3 squared, which is equal to what? 20. Then when I divide all through by 5, that means I will have x minus 3 squared, then this one will be equal to a 4. Then you take the square root on both sides, then this one will be plus or minus 2. That means x is going to be, when you take this on this side, you will get a 3, then plus or minus 2. Now for x, which is equal to, this is 3 plus 2, which is a 5, okay? What will be the y? I can substitute here or in here, but better to substitute in this one, okay? So 2 times your x, which is a 5, then minus the 4. What do you get here? You get 10 minus 4, isn't that a 6? No, actually they said the x coordinates, okay? They don't want the y coordinates, okay? So I'm just going to write my answer here as x is equal to 5. See that? Then here, the other x coordinate is going to be x is equal to 3 minus 2, and then it becomes a 1, like that. Question 10 is coming from circular measure. The diagram shows a sector CAB, which is part of a circle with center C, a circle with center O and radius R. Question 10 is coming from circular measure. The diagram shows a sector CAB, which is part of a circle with center C, a circle with center O and radius R lies within the sector and touches it at D, E, and F, where COD is a straight line and angle ACD is theta in radians. Part A, find CD in terms of R and sine theta. Now what are we going to do here? We know that in circle properties, the radius is always perpendicular to the tangent, okay? So that means this angle here is 90 degrees. the same with this one here. Okay, in fact, let me also add it there. This one here will also be 90, but let me make it dotted just like that. Okay, now they want CD. Where is CD? This is CD here. Now, from the center of the circle to the circumference, that is an arrow. So we have arrow here. We must have an arrow here and then here. You see that? So we have arrow and then arrow. Now, for us to get C to D, we need to get this length here, OC, then plus this arrow here. Okay? Now, when we have a right angled triangle, we can use SOHCAHTOA. Okay? Or Pythagoras theorem if we have only lengths involved. But if there is an angle, then we can use SOHCAHTOA. So using SOHCAHTOA, okay, relative to this angle here, this side is the opposite, then this one is the hypotenuse. So opposite and hypotenuse, I will use sine, okay? So we shall have sine of theta, which is equal to the opposite, that is r, out of hypotenuse, which is OC. You see that? So meaning, if I'm to find OC, I'll cross multiply, and then I have OC is equal to, so you also have the sine theta here, but then you are going to divide all through by sine theta. So you don't need to waste time. Just switch the two, okay? So you put the sine of theta here. That means our CD is equal to OC, then plus OD. Not so. OD. OD is here, which is R. So CD is therefore going to be, our OC is R over sine of theta, and then our OD is an R, and that is that. It is now given that r is equal to 4 and theta is equal to pi over 6. Part B, find the perimeter of the sector CAB in terms of pi. Now, we need to get perimeter of the sector CAB. Let's go back and check. Perimeter of the sector CAB. CAB. The perimeter of the whole of that sector. That means I'll need to get length of the arc AB, okay, length of this arc here, AB, then CB, okay, is the same as SC, not so? It is the same as that. So I will need this one here, which is equal to this. Then I also add on the length of the arc. But do you also realize that this length here, this CD here, is the same as CB and CA? It is the same. Why? This is an arc AB whose center is C. That means from C to any point that is on this arc, that will be the radius. Do you see that? So we shall have our SC is equal to BC. So I will say SC is equal to BC and is equal to CD. And we got that as R, then plus R over sine of theta. You see that? Then perimeter of sector CAB will be equal to, we have our AB. Let me go back and check. When we check, we have this one here, AC, then BC, and then the arc length, okay? Now, we need to find the arc length. Okay, if this one is theta, then even this one will be theta. Do you see that? So that means when I'm finding the arc length here, remember arc length is r, then times theta. So, but the theta here is going to be twice of it. Do you see that? Okay, now let's go. And we say that this one is going to be SC, then BC, SC, then plus BC, then plus arc AB. Now SC and BC, they are the same. So we have R, then plus R sine theta. This one I will multiply it by 2, okay, for these two. Then plus arc length, remember it is r theta. So I'm going to have the radius, which is the radius of that arc. Radius of arc, that arc AB is equal to the CD. You check here. When you check here, the radius of this arc here, this is the one here, which is equal to CD, which CD we got it, okay? And that CD is actually R plus R over sine theta, then times 2 theta. I told you the angle is what? 2 theta. Then we can now substitute our R. R is 4. So we have a 4, then plus 4, then sine theta is pi over 6. Sine of 30, that one gives us a half answer. Then we shall multiply by 2, then plus the same thing, 4 plus 4 out of sine of pi over 4 over 6. Then times 2 times our theta is pi over 6. Let us simplify this. This one is a half. 4 out of a half, that will be 8. 8 plus 4, that will be 12. 12 times 2, that will be 24. Then let's come to this one here. We have seen this one is 12, okay? And then this is pi over 3. So you have 12, then times pi over 3. So this one goes here 4 times. So we shall have 4 pi there. So plus 4 pi. That is our answer here. And then part C, find the area of the shaded region in terms of pi and root 3. When you go back here and you check, okay, we can say, don't say area of this sector minus area of this circle. There are these other parts which are remaining. You see that? So if actually this one was shaded and also this one was shaded, then we would have said area of this big sector minus area of the circle. As simple as that. But since we have this area and this one here, now what we are going to do, we are going to get area, let's say, of this triangle here. Do you see that? When you get area of this triangle, then you also get, which is the same as the area of this other triangle. So you multiply it by 2, you would have gotten the area of this. Then subtract off the area of this sector here. You see that? Now I want you to see what is happening here. They gave us this part here, okay? R is equal to 4, and then part B and part C, they are all under this stem. You see that? So what is our OC? When we check here, remember I need the area of this triangle here. So I know this one is 4, but I can get this one OC, because OC, we got it as R over sine of theta. You see that? So when I get this one here, And I also have this one. I can use Pythagoras theorem to find this CF. After finding CF, then I can say a half times this base, then times this height. You see that? I can be in position to get the area of that triangle. Okay, now let's go. So we have area, no, I mean OC. OC is equal to 4 over sine of theta. So we shall have 4 over sine of pi over 6. This is a half, so 4 over a half. That one gives us 8. Okay? We are done with that. That means using Pythagoras theorem, on triangle, which one? The triangle here is OCF. We shall have CF, which is equal to, it is equal to what? You can see that this is a 4, and then this one is what? 8. So I would say 8 squared, then minus this 4 squared under the square root. 8 squared minus 4 squared. This is 64 minus 16, that is 48. So we shall have root of 48. You see that? Now area of triangle OCF is equal to a half times the base. Remember, the base I told you can be this one here, and then the height is this. Okay, so this is 4, and then the root of 48 we have gotten here. So 4 times the root of 48, and then this one will be 2 root of 48. But root of 48 is the same as 16 times 3, 16 times 3. So this will be root of 16, that is a 4. So you have 4, then root of 3, okay? Then there is a 2 here, so times this, that will be 8 root of 3, not so? So I'm going to keep 8 root of 3. These are centimeters what? Squared. Now, after that, we can now have area of the whole quadrilateral. Area of, now the quadrilateral here is, it is OECF, okay? OECF is going to be equal to 2, then times this one, okay? You have 8 root of 3, which gives us 16 root of 3 centimeters squared. By the way, where the units given in centimeters, let's check. R was given in what? R, they never gave the unit, okay? So don't put the centimeters there. Let us just leave it like that. Then after that, we shall now look for an angle. Now let's go back to this. We got this angle theta here as pi over 6. That means this one will be pi over 3. Okay, even this one, because these two triangles are congruent, this one will be pi over 3. Because this is 30 degrees, this will be 60 degrees, such that these two give you a 90, which you add to this 90, and then you get 100 and what? 80. You see that? Now, we want to find area of this arc, I mean area of this sector here. So I will get the angle is pi over 3 times 2. You see that? So it is, we get this one, then times 2. Then after that, that will be, I think, 2 pi over 3. So I will say that now angle right from here, I will say angle FOC, okay, because we need it. angle FOC is going to be equal to pi 180 minus the other pi over 3. I mean pi over 6. 180, there is this 90 and then this one, okay? Sorry. We shall have minus also 90, which is pi over 2. So meaning you get pi over 3. So meaning angle FOE, this angle here, FOE will be twice that, okay? So that one will be 2 times this pi over 3, like that. Then we get area of minor sector, the minor sector FOE, okay? That one is going to be, remember, it is a half r squared theta. So the radius is r, of course, but that r is a 4, so 4 squared. And then the theta is this one here, 2 pi over 3. Then this one simplifies to, this one will go. Then we have 16 over 3 of pi. 16 over 3 of pi. Then from there, shaded area, the shaded area shall be equal to area of this quadrilateral we got, this one here, then minus area of this segment. So we shall have 16 root of 3, then minus 16 pi over 3. If I want, I can put the 16 outside, then you have root of 3, then minus pi over 3 square units. And that is that. Question 11 is coming from functions. The functions f and g are defined by these ones here. Then part F, find an expression for fg of x. So fg of x, that means you are putting g into the f. So if f of x is x squared, then plus 3, that means where there is x, I'm going to put the g of x. I'm going to have something like that. Remember, it is x squared, then there is a plus 3. So we shall have 2x plus 1 squared, then plus 3. You can even leave it there like that, or you can simplify it and you say expand here. When you square the 2x, you get 4x squared, then 2 times this times that, you'll get 4x, and then when you square the 1, you'll get a 1, then plus the 3. So meaning what you're getting here is 4x squared plus 4x, then plus 4. So just like that. Part B, find an expression for the fg inverse of x and state the domain of that fg inverse. Now, this g of x here, fg of x, I'm going to use this one here, is equal to 2x, then plus 1 squared, then plus 3. Now I'll let my f g, then inverse of x, to be equal to y. I can take this one this side, so when I take it there, that means x is going to be equal to fg of y. That is the same thing as saying interchanging x and y, okay? Now, where there is x in here, I'm going to interchange, and then I put y. So we shall have 2y, then plus 1 squared, then plus 3. Then from here, we are supposed to make y the subject of the formula. So you bring the 3 this side, it becomes a negative. And then after that, we shall have 2y, then plus 1 squared. Now you take the square root on both sides. We shall have x minus 3, but here we shall have plus or minus, because whenever you take the square root, that is what you must do. Then bring the 1 this side, it becomes a minus, so plus or minus, then the root of x minus 3, which is equal to 2y. That means y will be equal to negative 1, then plus or minus the square root of x minus 3 out of 2. Then this means that our fg inverse of x is going to be negative 1, okay, then the square root of x minus 3, then here we put a 2, like that. But we need to choose a sign, plus or minus. Remember, function is said to have an inverse if it is 1 to 1. Are we there? It must be 1 to 1. So you cannot have plus or minus. Okay. Now, we are putting g into the f. So when we put g into the f, now look at the domain of f, because you are composing this one into this, but the domain of f is this one here. Okay. Now, that means we are going to have, we are looking at the positive side. Okay. So this one here is a what? Is a U-shaped curve, and it cuts y-axis at here. Okay. So we are having this point here as the turning point. Now, if that is the turning point, then this simply implies that we can either use the left side or the right side, okay, if a function is to have an inverse. This one doesn't have an inverse because it is not 1 to 1, because we are seeing one value of y can be given by two values of x. So we have x2 and we also have x1. So in order to make this function have an inverse, then we must look at one side, either the left side or the right side. Now we are looking at the right side here, greater than 0. You see that? So because we are looking at the right side, then you take the plus sign. If we are looking at the left side, then we would have taken the plus sign, the minus sign. So here I will take the plus sign. I'm not going to prove that now because I've been showing all of this in the papers that I've been doing before. So if you are looking at the right side of the function of the turning point, the domain is looking at the right side of the turning point, then you will use the plus sign. If it is at the left side of the turning point, then you will use the minus sign. As simple as that. Now we need to find the domain of the fg inverse. Now when we go back here, since the domain of f here, okay, is all positive values, okay, all positive values of x. Now for this function here to be valid, okay, what is inside the square root sign must be positive, okay, must be what? Positive. Now if it is positive, that simply implies the smallest this one can be is a 3, okay, the smallest it can be is a 3, in order for this one to give us, because if it is a 2, then you have 2 minus 3, that one will give you a negative 1, so you will not have the square root of a negative 1, it will be undefined. So x here has to be equal to what? To 3 and bigger, okay, and bigger what? Values. So I will say for fg inverse to be valid, okay, the square root of x minus 3 must be greater than what? Must be greater or equal to what? To 0, okay, because this one can be a 0, and then you get this value negative a half. So for x, this therefore implies that x has to be greater than what? 3. X has to be greater than what? 3. So this has to be the domain. This is now the domain of the fg inverse. Part C, solve the equation fg of x minus 3 then is equal to gf of x. Now, this one here, let us first write our f of x. we saw that f of x is either this one here, sorry, x squared plus 3, then 2x plus 1, that is the g of x. We have x squared plus 3, and then the g of x is 2x plus what? 1. So our g f of x, we have seen it as 4x squared plus 4x then plus 4. Okay? Then g f of x. Now put f of x in the place of what? X here. So this one will be 2, then into x squared plus 3. Then plus a 1 here. So meaning we shall now have this 4x squared plus 4x then plus 4. Now I'm substituting here. So there is a minus 3. Then I will equate to this one here, which is 2, then x squared, then plus 6, and then plus 1. So we have 4x squared plus 4. This one will give you a 4x, then plus 1. Bring everything to this side. We shall have minus 2x squared minus, this will be a 7, then is equal to 0. So we get a quadratic from here, which is 4x squared minus 2x squared, and that will be 2x squared, then plus 4x, and then 1 minus 7, that one will be minus 6, which is equal to 0. Divide all through by 2, you'll get x squared, then plus 2x, then minus 3, which is equal to 0. Solving these two numbers, when you multiply them, they give you negative 3, but when you add them, they give you positive 2. That will be negative, that will be positive 3, and then negative 1. When you add these two, you get the 2. And then when you multiply them, you get the what? The negative 3. So that will be equal to 0. So you will get x, which is equal to 3. And you will also get x. No, it's not 3. It's a negative 3 because this one is a positive. So when it crosses the equal signs, it becomes a negative. And then x here is going to be equal to 1. Now, we need to choose one of these values. Okay? Now, since we are using f of x, whose domain is this one here? Okay? Whose domain is this one here, x greater than 0? And then the g of x, the domain is greater than, the x values must be greater than negative 0.5. Okay? And one of the values here, negative 3, is far less than the negative 0.5. So our answer has to be equal to 1, which satisfies both. And that becomes that. Question 12. The diagram shows a curve with this equation for x greater or equal to 0 and a straight line with the equation y is equal to 3 minus x. The curve crosses the x-axis at point A, 40, and crosses the line and crosses the straight line at B and C. Part A, find by calculation the x-coordinates of B and C. That means here we are going to solve the equation of this curve and this straight line simultaneously. Okay, so we shall have for intersection of these two, then 4x to the power of a half minus 2x will be equal to 3 minus x. Then I can take this minus 2x this side, such that on the left side I'm only left with this term with the square root. Okay, so that one makes it easy to square, and then the square root disappears. Okay, so we have 4 x then to the power of a half, which is equal to 3 minus, when this one comes here, we shall have minus x then plus 2x. So meaning we have 4x to the power of a half, which is equal to 3. And then this one will be minus, I think it will be plus x. Then we can square both sides. Okay, square both sides to do away with the square root sign. So you have 4x to the power of a half, we square it, then this one will be equal to 3, then plus x, and then we also square it. So that means we shall have a 16x here, then square the 3, that one will be a 9, then plus 2 times 3 times x, that will be 6x, and then square the x, that one will give us x squared. So bringing this one this side, we shall get one quadratic equation, which is x squared. 6x minus 16x, that will be negative 10x, then plus 9, which is equal to 0. Two numbers, when you multiply them, they give you positive 9, but when you add them, they give you negative 10. We shall have negative 1, and then negative what? Negative 9. This one is equal to 0. So this simply implies that our x is going to be 1, and then the other one, x is going to be equal to 9. So those are the two x coordinates of B and C. Then they are saying show that B is the stationary point on the curve. Now we know that for stationary points, dy dx is equal to 0, not so. Dy dx has to be equal to 0. Now we have our y, which is equal to 4, then x to the power of a half, and then what else? We have minus 2x. Now we need to find dy dx, then we get the x coordinate of B, we substitute it in the dy dx we get. If we get a 0, then that implies that B is a stationary point. So bring this one down here. So a half of 4, that one will give us a 2, and then reduce this one by 1, you'll get negative a half, then minus a 2 here. Now the x coordinate of B, okay, at B, x is equal to what? If we check the diagram here, the x coordinate of B is the smaller one, okay, and amongst these two, it has to be this one here, not so? So then when we come to this one here, we shall say at B, x is equal to 1. Then what will be now the value of dy dx? This will be 2 out of, I can take this one down using rules of indices, so it will be the square root now of 1 minus 2. Square root of 1 is a 1, then 2 over 1, that is a 2 minus 2, that will be a 0. So therefore, B is a stationary point because dy dx is equal to what? 0. So B is a stationary point, and that is that. But see, find the area of the shaded region. Now area of this shaded region, we shall have the one which is above, then minus the one that is below. Since this one is even a straight line, we shall look at area of this triangle here, okay? Area of this triangle from here up to here, then minus area above this curve here, not so? So we are integrating for the area of the curve. We shall integrate from this 4 here to this x coordinate here, which is a 9, okay? Now we need to know where this line, okay, where this line is intersecting the x-axis, not so? Where that line is intersecting the x-axis, when x is equal to the 9, okay, this one is the 9 here. Remember, I need this point here. So the equation of the straight line is the one that I was looking for. It is here. On x-axis, we know that y is 0, not so? So I will say on x-axis, y is equal to 0. So this one, y is equal to 3 minus x. You'll have a 0 here, then 3, then minus x. That means x is going to be equal to 3, okay? So that means when I come back here, this point here, the x coordinate is a 3. Now this one is a 4. Then this one here is a 9, the x coordinate of C, not so? So that one will give us a triangle. Now, when I'm finding the length here, then it is going to be this 9 minus 3, which is a 6, not so? And then the height will be the y coordinate here, okay, of C, okay? Now, I'll come to this and I say that for x is equal to 9, that is the x coordinate of C, okay? Then y is going to be equal to what? The equation of the curve is even this one, the straight line, because it is the point of intersection. So I can use the equation of the curve or the equation of a straight line. So let me use the equation of a straight line. That is 3 minus the x, which x we have seen it is 9. So we shall have 3 minus 9, which is equal to negative what? 6. So we are having this C here as negative, no, 9, and then negative what? 6. So this length here is 6 units. We shall not use negative 6. You see that? Okay, now let us find our shaded area. So shaded area shall be equal to area of triangle minus area, okay, above the curve. Area above, usually we say under the curve, so above the curve. Now, area of the triangle is a half base height. So the base, we are seeing here that it is this 9 here minus the 3, and then the height is this 6 here, okay? So I will say this one is going to be a half times 9 minus 3, then times 6. I'm using 6, not negative 6, because length cannot be a negative, right? Then minus, we are now integrating area under the curve. We are going to integrate from which point? Here, where a is a 4, and then, where the x coordinate is a 4, and then here, where it is a 9. So we are integrating from 4 then to 9, and the equation of the curve is 4x to the power of a half, then minus 2x, then with respect to x. So this one will be 6, then times the 3 that comes from 6 over 2. 6 times 3 isn't that 18? That will be 18. Then minus, when you begin the process of integration, you take away the integral sign. So we shall have the integral sign replaced by the square brackets here. So we simplify this. We integrate this one here, raise the power by 1. So a half plus 1, you get 3 over 2. Then you divide by the new power, then minus 2x squared, then over 2. Then we put 9, and then the 4. This one will be 18 minus. Then we have this one will go with somersault and then finds the 4, it multiplies with it. We shall have 8, then over 3 of x to the power of 3 over 2. Then minus, of course, the 2 will cancel, and then we shall have x squared, then put a 9, and then put a 4. So we shall have 18, then minus, let us put a 9, that will be 8 over 3, then 9 power 3 over 2, minus 9 squared. Then after that, we subtract, and then we put the lower limit 4. So that will be 8 over 3, and then 4 to the power of 3 over 2, then minus 4 to the power of 2, then we close. Okay, then this will be 18 minus, what do we have here? Square root of 9 is a 3. 3 cubed is 27. Now we have 8 times, now the 27 over 3. This one will go here 9 times. Then 8 times 9, that is a 72, not so. then 72 here, subtract 81, then minus, what shall we have here? Square root of 4 is 2. Then 2 cubed is 8. Now 8 times 8, that is 64. So I will have 64 over 3. Then minus, this will be 16. So putting everything in the calculator, okay, here we shall have negative 9, then minus 64 over 3. Then a minus will affect this minus, and then we have a plus. And so you should know that this area under the curve, or above the curve, what we are having here, this area, the shaded region, this area is actually below the curve. So we can get a minus, okay? We can get a minus because it is below the x-axis. Now let us see what we get here only. So we have 18, then minus negative 9 minus 64 out of 3, then plus 16. This one is negative 43 over 3. Okay, now this one here is the area, okay, under this curve or above this curve. So the area of this one is 18. Now the area of this one is a negative, but area cannot be a negative. You see that? So I'm going to put modular signs here such that it becomes a positive. Okay, it's an absolute value. So minus 43 over 3. Now you have 3 times 18, that is 54, minus 43. So you add a 7 to 43 to make it 50, and then plus the 4 to go to the 54. That one will give us 11. So we shall have 11 out of 3. That is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.